G'day guys, in this particular video I'm going to be showing you how to solve a second moment of area problem. And here we're asked to find the second moment of area about the x-axis for the triangle below. And as you can tell, this is a triangle of base b, height h, and the axis which we're dealing with is located at this vertex just here. Okay? So the first thing we do is we recall the formula that the second moment of area, also sometimes referred to as the area moment of inertia, about the x-axis is equal to the integral of y squared dA. Now it's worth clarifying here that I'm going to be solving this problem using the double integral method, so hopefully you're quite familiar with that method yourself. Okay, let's get started. What we need to do is we need to first draw a small element of area dA that makes up our shape. This is an element of area dA, and it's going to be equal to dx times by dy. Now, the way we're going to be solving this is we just substitute for dA here. And notice, because we've made the selection of dA like we have with two infinitesimals, then we're going to involve the double integral. So let's write this integral here, let's write this second integral here, then we've got the y squared here, and we can choose to express dA as dx dy, or let's mix around a little bit, we can express it as dy times by dx. Your answer will be the same, but the process will be a little bit different. Oops, sorry, that's dy times by dx, just here. Okay, so first things first, let's sort out what these limits of integrations will be. Well, because we're dealing with a dy in our first integral, that means we look at the limits of what this element swoops out. So this element will go from this point, which is y equals 0, to this point, which is, well, what is it? Well, this is a line, right? And this is a line going through the origin here, which is the equation y equals rise divided by run, so that's h divided by b times by x. This is the equation of the line. So that means that our element swoops out a range from y equals 0 to y equals h on bx. So this will be from y equals 0 to y equals h on bx. Okay, now now that we've got this small slice sorted, now what does this slice swoop out? Well, it goes from x equals 0 to x equals b. It goes from x equals 0 to x equals b. Okay, notice that this would be a different looking equation if we had the dx on the inside and dy on the outside. So let's do this. First we do the inner integral, then we do the outer integral. So let's write this in. This will be the integral from 0 to b of, let's see, what does this evaluate into? It'll be y cubed on 3 with limits from 0 to h on bx, right? And don't forget, we still have that pesky dx here. Now let's evaluate this. This will be 0 to b with the inside looking like this. We're going to get y cubed on 3, I'll factor out the 1/3 just here, and then we're going to get y cubed, which will turn into h on b x all cubed minus 0 cubed, right? And then we've got a dx just here. We can factor out the 1/3 right now because it's just a constant, so it's going to be 1/3 with the integral from 0 to b of, let's see, this will be h cubed on b cubed times by x cubed, and we're integrating over dx, so then this turns into a more traditional integral which we're used to, and this will look like, let's see, bring this out the front, that'll be h cubed on 3b cubed, let's see, integral of x cubed, that's going to be x to the 4 on 4 with limits from 0 to b, and this looks like, well, we can group the 3 and the 4 in the denominator, so let's do that. That'll be h cubed on 12b cubed, and then we're timesing that by b to the 4 minus 0 to the 4, and then we're left with, let's see, the b cubed and the b4 cancel out slightly to leave us with bh cubed over 12. That is our answer. This is our second moment of area about our x-axis, for a triangle of base b, height h, with our axis located at this vertex just here. Notice you would have got the exact same answer if you mixed the dx first and the dy afterwards. The process just would have been a little bit different. Okay? That's your answer. Cheers.